Hello children, in this lecture we will discuss nitrogen. So as you all know that of group 15, first element is nitrogen, which symbolized with N, and its atomic number is 7, and the configuration is 1s2, 2s2, 2p3. So in outermost p subshell it is having 3 electrons. Now nitrogen is the first element of group 15 of the periodic table and has the electronic configuration 1s2, 2s2, 2p3. In its elemental form, it exists as a diatomic molecule N2, and in this case molecular mass of nitrogen is 28. The molecular form of nitrogen is referred to as dinitrogen. So nitrogen is a diatomic molecule. Occurrence: nitrogen is present both in free state and also in combined state. So in free state, molecular nitrogen constitutes about 3/4 of air, and which is equals to 78% by volume. In combined state, it is present in the form of sodium nitrate, which is known as chili saltpeter, and ammonium salts. Nitrogen is an essential constituent of all vegetables and animals' proteins, which are vital for the process. So all the proteins are nitrogenous compounds having nitrogen. The next heading is preparation of nitrogen. Preparation of nitrogen or preparation of dinitrogen. Dinitrogen N2. So a laboratory method. This time you are having just one method, which is by thermal decomposition of ammonium dichromate. Only this layer preparation you are having in your syllabus this time. So dichromate, ammonium dichromate, when it is heated, it decomposed and form nitrogen, water and chromic oxide, which is green in color. So by thermal decomposition of ammonium dichromate, when red crystals of ammonium dichromate are heated, a violent reaction takes place, which is accompanied by flashes of light and evolution of nitrogen. So this is the decomposition reaction of ammonium dichromate, formation of nitrogen and chromic oxide. The next heading is properties of dinitrogen. First, physical properties. It is colorless, odorless and tasteless gas. It is non-poisonous, but animals die in an atmosphere of nitrogen for want of oxygen. Okay students, so itself not poisonous, but in the atmosphere of nitrogen, due to lack of oxygen, animals can be die. Next property is it has very low solubility in water. And after this, chemical properties of dinitrogen. So dinitrogen is almost unreactive at ordinary temperature. It neither burns nor supports combustion. The chemical inertness of dinitrogen at ordinary temperature is due to high stability of an triple bond N molecule. So due to the presence of triple covalent bond, N2 is a highly stable molecule, and that is why about inert in nature. Okay. Due to very high bond dissociation enthalpy, dinitrogen is almost unreactive towards most of the reagents. but at high temperature it combines with some metals and non-metals and forming compounds. So first chemical reaction of nitrogen is combination with electropositive metals. So nitrogen is combining with highly electropositive metals at high temperature, forming their nitrides. For example, with lithium, nitrogen is forming lithium nitride. With magnesium, magnesium nitride, and so on. The next is combination with non-metals. So nitrogen is reacting with non-metals, forming their compounds, and the first reaction is combination with dioxygen. So with oxygen, nitrogen is forming nitric oxide. Nitric oxide in the presence of electric arc about 3273 Kelvin temperature. Okay, students. Now this time you are not having a preparation of ammonia. This ammonia topic you are not having in a syllabus. So this reaction is also not there. Okay, students. Then third is reaction with compounds like Al2O3, aluminium oxide, and calcium carbide. So dinitrogen also reacts with certain compounds and forming their related nitrides. For example, with aluminium oxide, nitrogen is forming aluminium nitride. With calcium carbide, nitrogen is forming calcium cyanamide. So this calcium cyanamide is a very important fertilizer. Then uses of dinitrogen. So there are number of uses of dinitrogen, and out of those uses, few important are: main use of dinitrogen is in the manufacture of ammonia under Haber's process. Then calcium cyanamide, which is used as fertilizer and in the preparation of nitric acid. So ammonia is converted in the form of nitric oxide, then in the form of nitrogen dioxide, and at last in the form of nitric acid. Okay. Now second point, it is used for the providing inert atmosphere. This is very important use of nitrogen these days. Inert atmosphere with the help of dinitrogen. Then third point, liquid nitrogen is used as a refrigerant to preserve biological materials and in freezing food articles. It is also used in cryosurgery. So this cryosurgery is a modern term in medical science, cryosurgery, and according to this term cryosurgery, cryosurgery is a type of surgery that involves the use of extreme cold to destroy abnormal tissues like tumors. Okay, students. So under cryosurgery we destroy abnormal growths or abnormal tissues, or you can say abnormal cells, especially cancerous cells, with the help of liquid nitrogen. So liquid nitrogen freezes these cells, and these cells will be destroyed. Then fourth point, it is used as an inert diluent for reactive chemicals. Okay, students. So these are the uses of nitrogen. Thank you very much.